Welcome, guys, to a brand new week. Hope you had a great holiday weekend. And so on day 5, we're actually going to be switching gears a little bit. We're going to be going back to graphing. So we're not really going to be solving necessarily, but we're going to be graphing, absolute value functions. And then we're going to be dealing with transformations where we transform those functions. Now, when we think of graphs, we think of, a lot of times we think of the graphs we've dealt with, right? Like we think of like a diagonal line or a vertical line or a horizontal line. Well, this is different. Absolute value, their graphs are unique. And so to remind you, absolute value is whenever you have the bars, like absolute value of x minus 3, or the absolute value of negative 3, or let's go of negative, turn that into an 8. So, or the absolute value of negative 8, which becomes, when you take the absolute value of a number, it becomes positive. So we see that. So let's see what we're doing here. So we want to be able to transform different representations of functions, specifically absolute value functions. So we're going to be transforming absolute value functions. Well, it's probably good to know what absolute value functions actually are and look like. So an absolute value function has a V-shaped graph that opens either up or down. And you're probably thinking, wait, why not left or right? Why not left or right? Why does it have to open up or down? Look like, why does it have to look either like that or like that? Well, remember, this is a function. It has to pass the vertical line test, the VLT. So when we draw vertical lines, we see pass, 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 passes, passes, passes. What would happen if you had left or right? If it opened to the left, ooh, that fails. If it opens to the right, ooh, that fails. So these will not be functions. The only way that these absolute value graphs are functions are if they open up or down. So, not a transformation, a translation is a shift. It's when you move horizontally, that means left or right. Vertically, that means up or down or both. The result of a translation is a graph. Look here. The result of a translation is a graph with the same size and same shape, but in a different position. So when you translate, you kind of move left, right, up, down. You could potentially flip it, but we are not we don't make it bigger, we don't make it smaller. So our original, let's check this out. Our original absolute value function, there are the bars, is y equals the absolute value of x. That's the OG. That's the OG. Now, when we want to move it, by the way, this thing is a graph whose vertex is at 0, 0. So this graph kind of originates right here at 0, 0. So if you want to translate this graph, if you want to move it up, left, down, or right, here's what we're going to talk about that. This is our toolbox down here. This is our toolbox. So if you want to translate up, you're going to have the output's going to equal the absolute value of x. Close those bars. And then we are going to add a number. In fact, I'm going to do this in a different color so you can really tell what we've done here. We add a number. Well, what do you guys think that means for translating down? Try translating down here. What do you think that's going to look like? You can write it down if you think you got it. Y equals the absolute value of x minus a number. How about if you want to translate left? Y equals the absolute value of x. Now, wait a minute. I'm not going to close these bars. In fact, we're going to stay inside these bars. If you want to go left, you're actually going to add a number. So the absolute value of x plus a number. Because remember, normally plus takes us right, but inside the absolute value bars, it's the opposite. So that's left, that's down, that's up. What are you guys thinking for translating right? So if left had us adding a number inside the bars, again, I will make sure we see those bars there. And then y equals the absolute value of x. Some of you guys already know, minus a number. Y equals the absolute value of x minus a number. Now these last three are kind of tricky. These last three are kind of tricky. So if you want to reflect across the x-axis, here's what you do. Y equals. Now, in front of our absolute value, in front of the OG, you're going to put a negative sign. And so what that does is that actually causes our graph to flip upside down. Upside down. Yeah, it causes our graph to flip upside down just by putting a negative out front. Now, if you want to stretch, this is when if you put a number out front. So actually, this is going to be true for both of these. If you want to stretch, we need to put a number out front. So here was a negative. For stretch, we want to put a number. We'll call it A. So we want to put a number out front. Let's call it A, where A is a number bigger than 1. A is a number bigger than 1. So if you stretch, you got a number out front that is bigger than 1. What that happens is it causes your graph to be pulled from the ends, and it gets stretched. So it might look like that. It gets really skinny because you're pulling it from the top, which narrows it. And then compress is almost identical. Number out front. Except this time, A is a number that is, A is a number between 0 and 1. So A is a number between 0 and 1. Could be 0.5, 0.2. It's pretty much going to be like a fraction or decimal between 0 and 1. Okay, so these are our tools, guys. I want to have you pause to study. Pause the video to study these 7 tools. Go ahead. All right, guys. So we're going to finish up by doing 3 together and having you try 3. So let's go ahead and do this. Let's do these 3 together. So we know the OG looks like this. Let's see what's happened. We have 1/2 out front. Ooh, if you have a number out front that's between 0 and 1, that means we're going to explain what's happening. We're going to compress by 1/2. So what happens is when you compress, you have your graph and you kind of smash down on it, so it actually gets wider. It would look maybe something like that. It kind of widens when you compress on it. We also are moving it plus 2 at the end. That would be up 2. All right, number 2. Ooh, we got a negative out front. That means our graph is getting flipped upside down. So we would say negative out front, reflect across x-axis. So your graph is flipped upside down. We also have a 2 out front. Now remember, that 2 in the negative, pretend like that negative's not there. We just have a 2. And if you have a number out front that is bigger than 1, which 2 is, then we are stretching. You're making that graph kind of thinner. So stretch by 2. Remember, the negative belongs to this. The 2 belongs to this. How about, finally, speaking of 2, minus 2 at the end. Oh, that would be, we're going down 2. Down 2. So last one I'll do with you guys here, number 3. All right, we got a 2/9 out front. So if you have a number out front that is between 0 and 1, which 2/9 is, we know we are compressing. You're making this graph wider. Kind of compresses it out like you're stomping on it. So compress by 2/9. And then we've got minus 1 at the end, which would be down 1. So I'm going to let you guys try 4 through 6 for me. You can go ahead and pause the video. All right, guys, so let's see how you did. Negative out front, we know that means we are reflecting across x-axis. We're adding 2 on the inside. Well, if you add a number on the inside, that means you are translating left. We're going left 2, and then add a number at the end. In this case, we're adding 9. That's going to be going up. So up 9. How about over here, 4/3? Now be careful. 4/3 is really like 1.3 repeating. Well, 1.3 repeating is a number that's bigger than 1. So we would be stretch by 4/3 minus 2. If you're subtracting on the inside of the bars, you're going right 2. And then minus 10. You guys are probably catching on. You subtract the number at the end, we're moving this thing down 10. All right, last thing, negative out front. We know we are reflecting across the x-axis. And then adding, and this one just has 2, we're adding 1.4. That would be translating up. Up 1.4. Sweet. So this is the end of part 1. Part 2 is in the next video. So I'll see you guys there. We'll see you down here.